Electric flux and Gauss's law. Objective: to understand flux passing through a surface. Electric field lines are an intuitive way of visualizing a field produced by charge distribution. The number of field lines passing through a given surface is called flux. Flux through a planar surface in a uniform electric field is defined as the product of electric field normal to the surface, E cos theta, and area of the surface S. This can be written as E bar dot S bar. Let us find the electric flux through a surface when electric field is not uniform. Consider an infinitesimally small area, ds, around a point. The amount of flux, d, phi, through ds is E bar dot ds bar. This can be integrated over the entire area to get the flux through the entire surface. Let us look at flux through a spherical surface of radius r due to a single point charge q kept at the center. Magnitude of electric field at any point on the surface is equal to kq by r square, and it is perpendicular to the surface area. E bar and ds bar are parallel to each other at every point on the surface. Hence, E bar dot ds bar becomes eds. E is constant, so it can be taken out of the integral. So, flux through the entire sphere is E into 4 pi r square, which is equal to q by epsilon naught. As you can see, the amount of flux coming out does not depend on the radius of the enclosing sphere. In fact, flux does not depend on the shape of the enclosed surface as the same field lines pass through both the surfaces. It depends only on the enclosed charge. If one more charge, Q1, is kept inside the closed volume, the flux through the enclosing surface becomes Q plus Q1 by epsilon naught. Consider another charge, Q2, kept outside the closed surface. Consider a field line due to Q2 that passes through the closed surface. The number of times this field line enters the closed volume should be equal to the number of times it leaves the volume. So, its contribution to the flux is 0. Similarly, field lines due to the charge outside the closed volume does not contribute to the flux. The result can be summarized in the form of Gauss Law, which states that the total electric flux that comes out of a closed surface is equal to the charge enclosed divided by permittivity of free space. You will study a more rigorous proof of Gauss' law in undergraduate physics.